Hi, in this video I will show you how to use MultigraphGNet for augmenting new multi-view brain graphs from a single-view brain graph template. This work is published and selected as poster presentation at Prime Workshop yielding MICCAI Conference 2022. First, I will explain how to install the environment to run the code. Then I will mention about the data representation of our framework. To begin with, you need to download the MultigraphGNet code from our GitHub repository. Then, you need to create and activate a Python 3 virtual environment using the following commands. To install the required dependencies, copy-paste the following command. Note that this is for CPU installation. For CUDA installation, copy and paste the following commands. In terms of data, we represent the multi-view brain graph for a subject as a state of adjacency matrices, where each adjacency matrix is a different view. Then, the DGN fuses these multiple views into a single view connectional brain template (CBT), represented as an NR times NR matrix, where NR is the number of regions of interest. Then, RDGN reverse maps this CBT to the original multi-view brain graphs, of which shape is the same as the input. To execute the MultigraphGNet code, you need to activate the virtual environment. Then, you need to run this script to train the DGN and RDGN networks. Also, you can run the train classifier script to train an SVM classifier to see the effectiveness of our framework on a binary classification task, such as normal contour and autism spectrum disordered subject classification. Also, you can play with the hyperparameters and specify the shape of the simulated dataset in the config.py file. Now I will make a quick demo about how to run our MultigraphGNet code. You can use the simulated data, or you can create a new one using this command. Now you can train the DGN and RDGN networks on this simulated data using this command python 3 train DGN rdgn.py. As you can see, training is running on CPU right now because I don't have a CUDA on this machine, and you can see the results on fold 0 for each epoch. Now training is done for the fold 0, and you can go to the corresponding folder to see the trained weights, testing results, and statistics recorded during the training for DGN and RDGN. Now the training of DGN and RDGN is completed for all of the folds, and you can see the mean absolute error bars in this folder. Now to train the SVM classifier, first we need to train DGN and RDGN networks for the other class as well. To do so, just change this variable to the dataset class 2 and apply the same procedure again. The training of DGN and RDGN for both classes is just completed. To train the SVM classifier, you need to run this command python 3 train classifier.py. Training of the SVM classifier for 5 folds is just completed, and you can see the testing classification results in this folder.